Conversions of the p-series. The p-series is a series of the form 1 over n to the p power, and it converges if p is greater than 1. It diverges otherwise. To see this, we use the integral test. We integrate 1 over x to the p dx from 1 to infinity, and we will see that if p is greater than 1, then the integral is 1 over p minus 1. And if p is between 0 and up to 1, then the integral is infinity, so the series diverges. The case where p equals 1 is already taken care of. This is the harmonic series, so it diverges. If p is not 1, then we evaluate the improper integral. The antiderivative of 1 over x to the p power is x to the negative p plus 1 over negative p plus 1. Using the fundamental theorem of calculus, we plug in t and 1. 1 to the negative p plus 1 is 1. Now there are two cases when p is not equals 1. If p is between 0 and 1, negative p plus 1 is positive, so the limit is infinity, and so the integral diverges. By the integral test, the series diverges as well. The other case is when p is greater than 1. Negative p plus 1 is negative, and so the limits at t to the negative p plus 1 is 0 as t goes to infinity, and so the integral converges, so therefore the series converges by the integral test. And so if p is greater than 1, then the limit at t goes to infinity of t to the negative p plus 1 is 0. And so we end up with 1 over p minus 1, but p is a finite number, so 1 over p minus 1 is a finite number. And so when p is greater than 1, the p series converges. The consequence of this is tremendous. We now look at the series, and if it looks like a p series, then we can say right away without any proof that the series converges if p is greater than 1. If p is less than or equals to 1, then we can say right away that the series diverges. For example, the series 1 over the cube root of n. It doesn't look like a p series, but if we rewrite it, it is actually a p series with p equals 1/3, which is less than 1, so the series diverges. The series 1 over n squared, it is a p series with p equal 2, which is more than 1, so the series converges. A big warning. Just because we integrate the function to get a finite number doesn't mean that the series converges to the same number. For example, the series 1 over n squared is actually pi squared over 6, but the integral of 1 over x squared is 1.